Hello, welcome to this video. In this video, we will see how to create our Shiny dashboard for US arrests dataset. It will be a good dashboard for beginners to practice and hands-on. Let me show you the dashboard. In the dashboard header, we have a title saying Exploring the 1973 US arrests data with R and Shiny dashboard. On the right hand side, we have got few social media icons linking to external URLs for GitHub, YouTube, and LinkedIn. In the dashboard sidebar, we have got three menu items. First is the data set to cater for data related information. We have tab box with tab panels. First tab panel is the about with description of dataset along with an image. Then we have data displayed in the DT table. We have the structure tab panel displaying the structure of the data and summary stats too. Second menu item is visualization, which shows different type of visualizations that were done as part of explanatory data analysis. Here we have multiple tab panels in the tab box. First tab panel shows the crime trends. Collapsible boxes displaying top 5 states with high and low arrest rates. Below we have a bar chart showing arrests trends across 50 states. The trend changes according to the arrest type selected in the select input. We do have a spinner which shows up when bar chart loads or refreshes. Next tab panel shows up interactive distribution, a histogram with box plot. Then we also have correlation matrix and a scatter plot. Notice also that we have conditional select input widgets that appear under visualization sidebar basis the tab panel selected. Last sidebar menu item we have is a map showing choropleth map of arrests across the states. It reactively changes with the select input widget. Let's move on to our studio. And before we begin, let us review the file structure this app is gonna use. We have three files, namely ui.r for UI components, server.r for all server sites computation and reactivity, a global.r file. This will serve as a helper file for us. Global.r runs when the app is launched. Objects defined here will be accessible to both ui.r and server.r files. It will also help us to keep the UI and server side code clean. Images and media used in the dashboard is stored in the www folder within the working directory. I have chosen three files structure for demonstration purpose. If you choose to have a single file structure, that is just the app.r with all UI and server components in it, that will work as well. Really up to you how you want to structure the files. Make sure that you are in the right working directory. Let's create a new file and save it as UI in the working directory. We'll load Shiny and Shiny dashboard packages. If not installed already, install them before loading. We'll begin with creating the skeletal dashboard and then start building on it and adding the UI elements one by one. We'll add the dashboard page, dashboard header, dashboard sidebar, and dashboard body functions. These are the three components of the dashboard page. Now create another file and save this as server.r. Add the server function. We will just use the bare minimum function so that we can run the app. Let's run this bare minimum and ensure we have the skeletal dashboard. Next, let us add a title to the dashboard header along with the width. Title equals width equals and rerun the app. Looks good. It's time to put the social media icons real quick. We'll define each of the social media href links as list items. A bit of HTML text here, but we'll get there. Text $li class as dropdown. Tags $anchor href, give the icon, text for the hyperlink, target as blank so it opens in a new window when clicked, and similarly we will do for other social media icons as well. Let's rerun our app. Good. Now we can see the title with the given width, social media icons on the right hand side. We are all set with the header part, and it's time to move on to the sidebar menu items. We'll define the menu items within sidebar menu function. We'll give this ID equals sidebar, and then menu item function. This is our first menu item. We'll call it as data. Tab name or landing page name as data and add icon to it. Similarly, add other two icons for visualization and map. Let us rerun the app. Alright, we got the menu items, but there is no landing page or so-called tab item yet. Let us move on to create the landing pages within the dashboard body. Let us review how we want tab item for the first menu item. We have a tabbed box. Inside that we have 4 tab panels, each tab panel having its own content. Tab items function, tab items function, this will have all the landing pages, and we are going to create for the first menu item saying tab item function, define tab name as data. Recall this is what we had when we created the sidebar menu for data. This also maps a tab item to respective menu item. Next we create a tab box, define the ID, width, and then the individual tab panels. First tab panel for the about page. We'll add an icon and a placeholder message tab panel 1 placeholder UI. We'll replace this with the actual UI element later on. Similarly, add rest of the tab panels. Let's rerun the app, and we now see the landing pages with tab box and tab panels we wanted. Once again, we will fill the actual content later. For the second menu item, visualization, landing page is pretty much same as we just made. A tabbed box with 4 tab set panels. Let me follow the same pattern and create it. Notice this additional argument value. Later we will use this argument inside the conditional panel to create select input basis the tab panel selected. Let's run that. Okay, so now we have the landing page for second menu item as well. For the third menu item, we will just have a box. Okay, so now we have the landing pages for all the sidebar menu items, and it is time for us to look at our data and create visualizations that we saw in the dashboard. Open a new file and save it as global.r. We'll use this as a R script to write the R code for now, and later we will clean it up. We are working with the USA arrests dataset. This comes with the R base. In order to know more about US arrest data, you can write $US arrests in the console, and that will show the help page. Assign the data to my data object. My data equals US arrests. Let us do a structure on my data pipe str function. Now this pipe operator comes with dplyr, so load dplyr. Now in case you don't have the dplyr package installed, please install it. We'll use the dplyr to support pipe and other data manipulation functions. You can see that the data has 50 observations with 4 variables. Each observation represents a state with the arrests rate for rape, assault, murder, and then we have got this urban population as well. Let's pull the summary stats on my data, my underscore data, pipe summary function. And this gives us the summary stats. Now let's look at few observations of the data, which will give us a better understanding of how the data or observations look like. Head, and we can see that data set has row names with the state names. We will add additional column variable with states for these row names. This will help us later for visualization and mapping as well. Row names on my data, assign it to states object. And then we will use the mutate function to add column to the data set. Mutate state equals states, the object we just created. So far we've got enough to fill the tab panels for at least the first sidebar menu item, and let's do that. In the server.r, let's add the reactive functions for structure, summary, and data table. Structure, create the output object structure, render print. We'll take the structure related code from global.r and paste it here. Same for summary, output object summary, render print, add the summary code here. As for the table, we are going to use the dt package. You can do this without dt as well, your choice. I have used dt for demo purpose only. Library dt. Again, if you're not, install this package, install this, and then load this package. Output object dollar data t, render data table my data. Perfect. Now we'll go to ui.r and add these output objects to the panels. Let's do it. Replace the placeholder with data table output with the output object. Same for structure, verbatim text output on the object structure, and same for verbatim text output for summary as well. Let us add the image and the description of the dataset as well in the first tab panel so that the first sidebar menu is all completed. Make sure that the image you're sourcing here is already existing in the www folder in your working directory, else you won't get the image. I have already downloaded and placed the image in the www folder, and it's just a matter of using it in the UI. I've added two columns here, one for image and the other for description. There are multiple ways to do this, but I've just added them as two columns. Let's rerun the app. And we now have all the tab panels with their respective contents. And it is time for us to make plots required for the second and third menu items. For the second menu item, visualization, we have got multiple tab panels here, and one of the tab panel was about the distribution. Let us make the histogram and box plots, and we are going to use Plotly. Plotly on my data. Load the Plotly library in order for us to create the Plotly plots. Add underscore histogram on the variable rep. For a box plot, say my data, Plotly on it, and then add box plot on the given variable. And I want the box plot to be stacked on top of the histogram. Assign histogram to P1 object and box plot to P2 object, and then we'll use a subplot function to stack them. P2 comma P1, number of rows equals 2, so it will be one on top of the other. Add a bit of formatting to the charts so it looks better. We now have the distribution chart, but how do we integrate this with Shinydashboard and bring in the interactivity? We will define a select input with the options of variables to choose from, and these choices will basically be the column names from the dataset. We do not need the state names for choices, so we will drop them. My underscore data, select minus state. Remove this from the selection of variables and then names on it. This gives us choices which can be used inside the select input. Assign this to C1 object. Let us create the select input using this C1 object. First, create the choices for select input, and we want this in the sidebar menu under the visualization menu item. Select input, add the input ID, label choices as C1, and let's run the app. Okay, we got the widget. We want the user to select a variable and accordingly plot should change. To do so, we will need to use the input ID of this widget and add it to our histogram and box plot. Input ID here is var1. Just make a note of it. Replacing hardcode variable names with input ID var1. Looks good. Now we can use this in the server.r to produce interactive distribution chart. In the server.r, let's say output $hist plot render plotly to render plotly plot in Shiny, and we'll paste the entire plotly code we just created in this. At this stage, we have select input widget to choose the variables, plotly stacked histogram and box plot, and what is pending is to add the output object to the UI for display of this chart in the tab panel. Let's do it. We'll copy the output ID hist plot, and in the ui.r, let's locate the distribution tab panel and say plotly output on the output ID hist plot, and we are done. Let us rerun that. Awesome. On the similar lines, we'll create the scatter plot for the relationship between variables. Approach will be pretty much same. This time we are going to use ggplot for the scatter plot, and we are going to load the ggplot2 package. Along with this, I'm going to also use the ggtext package. This is just to format the labels. Notice this time we have two variables in use, and for the same reason, we will need two select inputs, one for x-axis or x variable and the other for y variable. Let's quickly create the two select inputs in the UI for this scatter plot. Okay, we can see the two select inputs now, and now it's time to use their input IDs into the scatter plot and then adding the scatter plot to the server.r. Okay, the input IDs are var3 and var4. Make a note of it and replace the hard-coded x and y variables with these input IDs. Update the titles as well. Okay, Now we can copy and paste this piece of code to the server.r inside the reactive function. Let's see, output $scatter render plot and paste the code. We can add a touch of plotly as well to this. Let's say gg plotly on p. Okay. In the UI, locate the tab panel for relationship and replace the placeholder by plotly output radio button with ID label choices, and let's take the input ID of this radio button to the plot section in server.r. Run the app, and this looks good. Okay, couple of things to note. All these select input widgets, they are appearing right from the load of the app. It's not looking so good and not how we would want. An alternate is to use conditional panel and control the appearance of these select input widgets basis a given condition. So under what condition shall we display these select input widgets? The first select input, this should appear when visualization menu item is selected, meaning the user is in the second menu item and user is in the distribution tab panel. On the same lines, the other two select inputs, which are for the distribution plots, should appear when visualization menu is selected and the user is in the relation tab panel. This translates to input.sidebar equals viz and input.p2 equals distro. Now, this seems to be a code here, but in simple terms, the meaning is sidebar menu item with the tab name as viz and tab panel with the value distro from the tab box select. Let us add these conditions into the UI using conditional panel. Okay. We can quickly add the core plot or correlation matrix and a bar chart to other tab panels. Let's create the core plot. We are going to use the gg core plot package. Creating bar chart using plotly. We now have the bar chart and the correlation matrix. To make the bar chart interactive, let us add the select input in the UI. Okay. Let us use the input ID of the select input widget and replace the hard-coded variables in the bar chart. Okay. Finally, to display the correlation matrix and bar chart, we need to add the output IDs. So let's make a note of these output IDs, bar and core, and go to ui.r, and this looks good. One thing we need to add to the trends panel is the list of top 5 states having high and low arrests rate for each of the crime types. We'll say my underscore data, select states and the arrest rate for rape, arrange them into descending order by the type of arrest. Displaying 5 of them shall give us the top 5. Similarly, for 5 states having least number of arrests in rape, we just need to change the arrange. Let us now create those collapsible boxes in the UI file. fluid row, we will have two boxes side by side. We want the header to be reactive and change according to the choice of arrest type selected by user as well. So let's go to the server code and let's write the reactive functions for headers. And let us also add the contents to the box in the form of table. We'll say output $top 5 render table and copy the code from global.r we just created. Okay. Now it's time to add the output ID from the server code, the output IDs we just created into the UI file to display the headers and the tables. Okay, awesome. Let us change the user input and see how it changes the bar chart as well as the content of the box and the header of the box. All right, so we now just have the last menu item for which we are going to create a separate select input and a map. Add the output for map as well, plot output on map underscore plot. We are going to use, we have already defined the map underscore plot. We will use the same output ID in the server and we will define the width of the overall box as 12. So select input as having a particular width and the map having the whole width of the box. To create choropleth map, we will be using the maps package. So let's load the maps package, and if you have not installed already, please install it. We'll take the boundaries from the maps package in the form of latitude and longitude and convert that to a data frame using ggplot package. Next step would be to combine the map boundaries data frame along with other information such as abbreviations of these states to the USArrests dataset. Okay, in the server.r, let's create the output ID, and if you recall, it was map underscore plot we already used there. Render plot, and let's create the map. Add title to the map and some styling to the text. Looks good. For the final touch, I see that plot's taking time to refresh each time user input is changed. For that sake, let us use the Shiny CSS loader package and add spinners to these plots. And it's very easy. In the UI, we have to just wrap the UI elements within the with spinner function to get the spinners out there. Let's do it. Okay, we can now see nice looking spinners there while the plots are loading. Looks nice. Before we conclude, let's also clean up global.r. We'll use global.r to load all the packages in one place. Let's remove the codes which are not used by either ui.r or server.r. I know we use this global.r as a R script for data manipulation and digging into the data. So let's remove all those codes not required to be in there. Okay. I hope this video tutorial was helpful. The app is hosted in Shiny Apps IO Cloud. Link to the app is given in the description section. And code used in the app is also available on my GitHub page. Link is given in the description. As a next step, try making changes to the app, add more widgets, add more features to it, and post your comments and share what changes you made